Hey family, can you hear me? All right, cool. So what I want to do, I'm actually uploading all the videos, and hopefully it doesn't. I'm trying to get all those videos up there, and hopefully it doesn't mess with the stream. So I have faith that we're gonna be okay. So this is gonna be all the videos up here, and they should be nice and clear. I downloaded them. I've been downloading them pretty much after each session, and I'm uploading them all into the channel. We only have one more that's uploading. If somebody says it's laggy, so what I'm gonna do is I'm gonna stop this video, cancel the upload. I'll upload that one once I'm finished, and what I'll do is I'll provide people with a link. So make sure that y'all get into the Discord. The Discord is gonna be in there. So I just have to upload one more video in here, and I'm gonna actually number them, and you can see that I have the dates here too. So they should be all there at the end of the day. All right, so I'm gonna whiteboard. What I'm gonna do is the whiteboard was so good last time. What I'm gonna do is I'm going to I'm going to get in here and I'm going to whiteboard as a recap for everything we did at the beginning. And then what I'm going to do after that whiteboard session is get into, we were doing subnetting and all that stuff as well. So I'm gonna do that. So be super patient with me. We're gonna get a lot of stuff done. All right. Okay. Cool. So I'm gonna give me 2 seconds. I was trying to get all that YouTube stuff uploaded and all that stuff, but now I'm I was trying to doing the YouTube work. So over here we're gonna do a review, and it's gonna be dope. So what I'm gonna do real quick is I'm going to go get a. I actually, since I was trying to upload and all that stuff and name those YouTube things. Give me a second here, and what I'm gonna do is I'm gonna get me something to drink, and I'll be right back. I'm gonna be right back. I'm just gonna go grab some stuff and sit back down. I just had a super funny moment. So my son, he's 14. He actually helped me set up this Twitch channel because he's a gamer, and he just said he joined the stream the other day, and he asked me who was Butch. Cause that's something I don't go around. I don't go. I don't rock with Butch normally. So, all right. So what I'm gonna do is I'm gonna rewind. I'm gonna make this. I'm gonna make this damn whiteboard available for y'all too. So we talked about a bunch of different things. So one of the things we talked about, we talked about the. Wow, that's super tiny. So we talked about the OSI model, and I told y'all that the OSI model is super very large. Is the OSI model? Well, am I that far out? That dang. So this tool that I'm using here is a really cool tool that I discovered over the last couple of days. It's called Acceleradraw. People's filling this tool. So I'm gonna go in and I'm gonna try to create some. I'm gonna try to recap, but I'm gonna recap and I'm gonna do it on the whiteboard. So basically we talked about the OSI model. And the OSI model, and for all the people that are with me here, this is like, you can, I don't think you can cover this stuff too much, to be honest with you. OSI model is, I'm just gonna put this out here. There's tons of acronyms. We're gonna go through this, and I'm gonna put it on here. I'm gonna put in these notes, and then when we're all finished, I can actually share this file, download it, and y'all can actually load it and look at my actual notes too. I love this way better than PowerPoint or anything. It's freaking dope. I like this thing. Transport, network, data link, and physical layer. And what's cool about this, as we said before, there's plenty of acronyms. Mine that I learned is please do not throw sausage pizza away. There's a lot of them. Please do not teach stupid. I don't know, somebody had a really good one in there. Somebody had something about pointless acronyms. Stupid, pointless acronyms, something like that. That was dope. I really like that one. So basically what we said on all these layers was a pretty cool thing. So what resides on these layers are different things. As we said, and I'm gonna draw some lines here. And so what's cool is on physical layer, you have stuff like, fiber optics, fiber. I'm gonna draw them right here. I'm gonna draw it out here so it doesn't mess up. So you got stuff like fiber, Wi-Fi signals, and here is fiber optics is what it is. So I'm kind of trying to peek in here. Fiber optics, Cat 5, like Ethernet cable, Cat 6, like all these different physical like mediums. These are things that the wires and stuff. This is what stuff This is how the data gets from point A to point B. I mean, this could be satellites. I mean, whatever, right? It's the actual electronics. So electronics. Like a lot of the physical science related to this, light, electronic signals, those kind of things. And that's what you need to know this, because to troubleshoot, sometimes you have to troubleshoot from starting off with the physical layer. Is the cable plugged in? is the power on? It's funny because IT crowd was pretty dope, and so does anybody the Discord? You don't have the Discord. Somebody sound like they don't have the Discord link. You don't need the Discord link now, but can one of the moderators stop that? I mean, well, so can one of the moderators please post the link to Discord? I appreciate y'all. If not, but Discord, I'm actually during the class. I'm actually looking at the Twitch stream for questions. Yeah, I have been advised not to do that, but I'm sorry for doing that. I kind of like feedback like that. So data link layer, I'm gonna say Ethernet frames, logical link control. Logical link control is what allows people to actually transmit on a wire. We talked about this CSMA CD, collision detection. There's also CA, I'm going to say collision avoidance. Many of those things are at this layer, right? So the Discord is for after class. There's a really good community of people participating in the Discord, teaching everybody how to do stuff. And my new favorite, I'm going to type this out. Please do not teach students pointless acronyms. This is my new favorite. So somebody, basically a way to remember these things. So network layer, what this gives you, this is IP addresses for the most part. So IP addresses, ICMP lives here. So what ICMP / and ping is a part of that. Those are ways for the routers to talk to each other. The routers and like routing traffic talk that way. The next one, transport. TCP and UDP reside there. Next layer. And so, in a sense here, people that have been paying attention know what I'm going to say here. I'm going to say there's this thing called remote procedure call, and that's the only thing I've ever heard people say that resides there. I'm just going to put that in just for, but I always say it, that doesn't really exist. Presentation layer, I'm going to say GIF and stuff like MP4, MP3, stuff like that. You can get different opinions, but I'm gonna say those things right there. And then up here, HTTP, this is application layer, HTTPS. I'm the type of stuff we normally use. POP3, SMTP. And trust me, even though this may be getting boring because I'm beating a dead, y'all might feel like I'm beating a dead horse, but really, this never gets old. You're always, if you're doing internet security, you're always going to be having these protocols are going to keep coming up and up and up and up and up again. So You know, there's no such thing as beating a dead horse when it comes to this stuff. I said GIF. Somebody said it's GIF, but even the creator said it's GIF. But all right, so man, this dang whiteboard. Are y'all feeling this whiteboard? I love this whiteboard. Typo on layer 5. RCP, that's right. This thing stands for remote procedure call. And my dog's about to go crazy. We ordered pizza tonight. Of course, contactless pizza delivery, so they're just dropping it outside. Gotta support the local community. I can't believe the dogs are not barking their heads off. All right. No, dogs are barking. Hold on a second. With somebody talking about virtual machines for the Mac. I like VMware Fusion. I used Parallels a long time ago. Let's try to continue to power through. All right. We also said that there was a DoD or DARPA model. I've heard this called a lot of different things. DARPANET, ARPANET. But let's just go with DARPA. The DARPA model was a little bit different. Application layer, and we said transport layer. This is where TCP/IP came from. There was an internet layer. This is where the IP addresses come from. And there was a physical layer down here. That physical layer. Hey, what the heck? Why are you in here? Stop. Physical layer and data link layer is the same layer. My dog is totally strong arming me right now. For cuddles. All right, so let me number these. So physical and data link with the same layer. You may see some people say this is data link layer. MAC addresses came from there. I've heard that also. I heard this be called the media access layer too. So essentially, this first one is a combination between the first two on the OSI model. This one is where the IP addresses come from. This one is where TCP/IP comes from. And this one is where the session layer, presentation layer, and application layer come from. So that's that. So basically, that's how that all works. All right. All right. Cool. Moving right along here. Let me see. All right. So what happened is I drew some huge triangles. I wanted to make those small. All right. Let me make these smaller because what I'm trying to do is teach one of my other favorite things to teach. Whoa, is it? I can't do that. All right, hold on a second. New tool, learn a little bit. Those are too big, so I gotta go in and draw them. I gotta go in and draw them tiny. All right, drawing more concepts that are near and dear to my heart. So what I'm gonna draw now is I'm gonna draw a triangle because one of the things I like to teach about is a CI triad. Somebody gave me, I don't know, I hope you're here today, but somebody gave me a, I teach the CI triad and also teach the opposite of the CI triad. Right? So all these things, this thing is pretty cool, and I like drawing anyway, so I'm a dork. So there's this thing. So basically, back in the day, the only thing we cared about was data, right? And when I first joined the Navy, we called computers and all that stuff. This is kind of weird, and it's gonna date me a little bit. We called all this stuff uh, automated data processing. This is what we called it in the military. I'm pretty sure that they called it some. They probably called it ADP in other different places. Has anybody ever heard of that? Has anybody heard of ADP? The military used to call it that. I need to get my dog away from me. She's tripping. It's funny because my office door doesn't lock, so they keep on coming in. Hey, hold on a second. Let me get rid of my dog. My dog's keeping me from typing. Yeah, so I don't know. Is somebody said ADP is the name of a company, but I don't know if it stands for that. Does ADP stands for automatic data processing, the company? Because I think the term that we use in the military was ADP. Funny enough. What does ADP? I'm googling this. That's crazy. Wow, that's insane. When were they founded? That's right. The company stands for automatic data processing. We called it automated data processing. So there's a little bit of nuance. The company was founded 71 years ago. It's Automatic Payrolls Inc. So, isn't that something? I used ADP before too, back in the day. So anyway, the military called it that, this, and we just cared about data. And then people started calling it information instead of data, and so people call it information security. There's a lot of different terms for this. And then when information security wasn't enough, a lot of people probably say network security. Matter of fact, my degree, I got a degree. I have a master's degree in network security, and what some other people call it now is cybersecurity. And some people, this is controversy. This is even controversial because some people will call it cybersecurity, like that. Some people call it infosec. It's all the same. These are all, to me, these are all the same things. So, whatever, this is funny to me because I think over time, What matters is the data. So no matter what people, no matter what people call it, that's crazy. That I think they must have took that. They must have just said, "All right, cool." They ADP changed their name to something to be this. It wasn't the original name, by the way, but I've heard all these different terms, and there are probably more terms, but these are the most prevalent ones I've learned over my life. So when I first got into Navy, everybody called it ADP. We had like ADP departments in the Navy. Now, the consistency though, because you know, oh, what I missed one. The one of them is this one. When I was at the agency back in the day, there was an information assurance group and stuff. All right. So there was these pillars. Confidentiality, integrity, and availability. Now that was the CIA triad. So basically, data needed to have these different things. Now what you'll hear, this is crazy. Now the CISSP used to drill this in. They call it the CIA triad. What's hilarious though is because people thought that this had something to do with the CIA, so people started calling it the ACI triad. Because anytime you mention CIA or NSA, people get crazy, right? So basically, I still call it the CIA triad. But what's the opposite of this? And I was telling somebody, and this is where I'm going to be paying attention to notes. Somebody actually really kind of blew my mind, because I've taught another thing. I taught the opposite of CIA triad was so what is that up there? Integrity, destruction. Or somebody said, oh, let me type what I know, and hopefully somebody can. Destruction. I'm gonna type this out because destruction, denial, and confidentiality is disclosure. Disclosure meaning you're disclosing what the data is, you're destroying the data, or you're denying the data. Now, somebody said DAD. What was that? What's the A for y'all? What's that DAD? I'm looking. Somebody said alteration. I can go with alteration. Alteration could be deleting it. So let's just call it the dad. It's like a dad joke. I'm gonna call it the dad. It's the dad joke now. That was a dad joke. All right, is this working? Yeah, I can't. It's not letting me type. Hold on a second. Yeah, let me delete it. So this is I'm gonna say DAD. All right, DAD. Let's call that the dad triad, because these are the things that we're trying to prevent as cybersecurity professionals. We're trying to prevent alteration of the data. We're trying to denial that is a DDoS or DOS attack kind of thing. What's interesting about this is and I tell people from time to time, what I really like is ransomware is like the one that actually ransomware. This attack kind of like really does it's pretty cool, because ransomware, from an attacker perspective, ransomware kind of trumps this whole situation here. Where ransomware does all that stuff. let's just roll with this, and the type of attacks here, DDoS. We've seen DDoS attacks. Disclosure would be basically disclosure attack would be what happened to Snowden. People when Snowden leaked all that data. Alteration of the data. A good example of that to me. Dang. What's the popular attack where people alter the data? I mean, ransomware fits in well with that because what ransomware does is this actually altering data, it's encrypting the data. So, and so basically that's what we're trying to do. We're trying to fight the good fight in cybersecurity, and we're trying to prevent all these bad things from happening. And somebody just said Maze, like ransomware. So some ransomware attacks ransomware is a denial of service as well, which is pretty, like I said, ransomware. I'm gonna put ransomware down here. Somebody just mentioned a Maze malware, ransomware attack. That group of people, they will definitely start leaking data if you don't pay for it. So yeah, so this is kind of like this is that thing. So it's important to remember that this is what we're always trying to do. Now, I'm gonna say. Oh, you know what? Somebody said defacement. That's a good example. I'll give you another one. Defacement. I was just thinking about deletion. So somebody can delete your database. So there's they can drop your tables. Is one of the things we can say. Basically, you got a database, they can drop tables all day. There'll be an alteration of the date as well. All right, so that's actually, and some of y'all have been with me every class. This whiteboard is actually helping me out a lot. I'm really happy that I found this whiteboard. So I'm gonna take questions real quick. I'm here. We're gonna do a really good review, and we're gonna try to get back into the network and stuff. Is this good? Seeing this this whiteboard is actually, I feel good about the whiteboard, and I feel good by talking about these subjects and illustrating it for y'all. Yep. So I'll give a copy of this as well. Everybody will get a copy of the whiteboard. Matter of fact, let me download this thing right now. So you can download the whiteboard right there, and what you can do is you can load it too. So when I'm doing these alterations, I'll do it. Yeah. So the DAT triad. You think of this whole DAT situation over here? This is what the attackers are trying to do to your network. Okay. So I'm gonna what I'll do is I'll upload this file, and I'm gonna put it in Discord. All right. It doesn't seem like there's a lot of questions, so either I'm doing a good job or y'all bored. So I'm gonna go with good job. All right. So what I want to do real quick is one of the things that I talk about encapsulation and decapsulation. Now, I wanted to display this the other day, and I found something that kind of would have worked, but there's another way I like to explain this topic. So we're talking when I talk about encapsulation, decapsulation, what I'm talking about is, and the best explanation I like of it is it explains these as all as these being envelopes. So say if there's an envelope, right? Okay, so this is going to look like an open envelope. That's the goal. I'm kind of like a aspiring artist. So this is an envelope. I'm just gonna make it. I'm kind of like, I got ADD, so if I don't do it right, I'll be hurting all night. So just forgive me for a second. I mean, I got OCD, so so if I don't do stuff right, it annoys the heck out of me personally. So we're gonna make this the inside of the envelope. It would be much faster if I had a real whiteboard. I think I'm gonna buy me a freaking one of those drawing pad things. All right, so say this is an envelope, close enough, right? All right, so this is an envelope, and so what I need is I need a bunch of envelopes. Paste. I need 7 envelopes. Six. Paste 7. All right. So I'm gonna zoom out a wee bit, and I'm gonna line these jokers up. Whoa! Didn't grab it all the way. Hold on a second. This is gonna. Hopefully, this is gonna unlock. If you didn't get it totally before, I'm trying to really unlock this so you'll know it really well. So my wife's from the UK. They have this game called Pass the Parcel, and this is what TCP/IP reminds me of. I like it in what I'm showing you is I'm showing you in elevator format. I mean in envelope format here. Because these envelopes, it actually explains what encapsulation and decapsulation means. So encapsulation means we're putting something in a bottle, or in this case, we're putting them in envelopes. All right. Hopefully this is not too big. Yeah, it looks great on here. Hopefully the writing doesn't suck. All right, so we got our envelopes, and so basically, I guess the best way to explain this probably is talking about email. So let's just have an email example. So you're in your email uses SMTP, right? So you have an SMTP client that'd be something like Outlook, right? This isn't too small, but I can actually zoom in and then just scroll down. So you're in your client, you're typing up an email, and that's what your SMTP client does. Now, there's all kind of different presentation layer things related to this. So I'm just gonna say a mime. I'm gonna say S mime. And forgive me if I type any of this stuff wrong. Basically, what this is a format for your email. It's like an encoding for email. And notice here, what I'm doing is I'm trying to break down these applications and applicate. So this is application layer. Right? All right. Let me just break these down. This is we're making each one of these an envelope. This is presentation layer. This right here is going to be your session layer. I want to have a session layer meme. This is your network layer. I'm wrong. Transport layer. Paste. It's gonna be network layer. Oh man. Network data link. Paste. Physical. All right, fantastico. All right, cool. So we're going down this. We're going down here. So we already said, hey, we're using the application we're using is SMTP. That's Outlook. Session layer. Y'all know how I feel about session layer. Transport layer, TCP. This is going to be, and because the reason why it's TCP, and we said it's connection oriented. That means email is important. We want to make sure that it goes in there. Sweet. So along here, SMTP. So basically, what you're doing every step of the way, you're putting new information into an envelope. You take the application layer, boom, then you stuff it into the presentation layer. We're going to pretend that the session layer exists, and we're going to put the email encoding into the session layer. It's like for extra protection. Somebody asked me the number of these. I'll do that. 1, 2, 3. So along the way here, what's cool about this is that each layer of this is going to be open by the layer on the other side. So this goes two ways. So, and I'll show you. What the heck am I doing? Am I doing this right? Yep, I'm doing it right. So people's, like when we go down the OSI stack, what we're doing here, this is called encapsulation. That's the technical term for what we're doing here. We're encapsulating it in this, like if you put a stamp on the thing, you put a stamp on these envelopes, we're like, hey, this is application layer. I'm encapsulating it here, and it's going to be open on the other side by the same thing. So when it gets to the other side, Outlook's going to open up, and you're going to see the email. The computer is going to understand that the encoding is this type of encoding. Network layer. We said we know that the network layer is for end-to-end routing. So at this layer, we're going to get IP addresses put on here. There's going to be 2 IP addresses. There's going to be a source IP address and destination IP address. So the source and destination are going to be my IP address because I'm sending it, And then that's how I know how to reply back. And it's going to be if I'm sending you an email, it's going to be your destination IP address. IP. All right. Now, data link layer. This are going to be MAC addresses. This is where the MAC address is. Last class I talked about this a little bit. The MAC address is going to be the MAC address of the next hop, the next switch or router. In here, source MAC and destination rack. Again, on this envelope, we can just say that each envelope is like a frame it's like a frame essentially. And every little data, every little frame, it's like you're stamping it on an envelope, folding it up, putting it into the next one. And the physical layer here, we said before, that physical layer is whatever, I'm going to say whatever electronic mean possible. So that could be Wi-Fi, that could be anything. You know what I'm saying? Like, you could actually, smoke signals could be a dang physical layer thing. Whatever it may be. Morse code back in the day. You can transfer data in any way, right? And when I say smoke signals, I'm not talking about y'all, the smoke signals some of y'all be doing. You know what I'm saying? So the IP address, the IP address, or let's so here, source and destination. MAC addresses are only locally significant, right? A router uses, when you talk to your default router, you're gonna send it to their MAC address. It's gonna be just like this. It's gonna fold it up into an envelope, and then the next layer, it passes it up to the network layer, and then it looks at the network layer and it makes a decision based on that. My dog's trying to come in, but I locked her out. All right, so that's how that works. So encapsulation, this works both ways. And then what happens with it is you're gonna, I zoomed out a little bit, and the reason why I zoomed out is because this is where it's sent. And I wanna right here, sent packet. Well, sent. I'm gonna say sent email, right? Because we're talking about email. All right, cool. So what I can do is I can copy this whole thing, because it's exactly the same thing on this side. The only difference is, and we're gonna zoom in here. That's gonna look all pretty. And what we call this is decapsulation. So decapsulation means we're opening up these envelopes. And this goes up the stack. Now, how this works in this way. When I send something across the wire, the destination MAC address is going to say, is my name Butch? Is this my MAC address? And if it is, it's going to open that packet up, and it's going to pass it to the next level. So here's the deal. If this was a router, it would have the source MAC address for most packets because it's sending the stuff out the network. But the next thing that the next device does is it's going to say, is this my IP address? Because it's opening up these packages. And if it's not, right, it's just going to like, all right, boom, I can just totally ignore this. This is not my IP address. So in this case, it is my IP address. Sweet. Let me pass this up to the next level because this is a TCP connection. This is super important and it must be delivered. I'm going to pretend like this session layer exists. But now I know that I have remember when I said the SPA, this thing right here? Hey, trust me, people use Morse code. Somebody said Morse represents the alphabet. People send binary stuff over. People send stuff over there. On my box over here. Hold on a second here. Let me just slide this over. Hey, good feedback. So my face is in the way. Let me try to make that smaller too. Why not? All right. So hopefully I fixed that. All right. So I would say, my bad. If I said, did I say Morse code over here? Let's just say I can say Morse code. That let's just say this is frequencies, right? This could be UHF or whatever. And my bad, because like a Morse code, if I was saying Morse code here, Morse code would be more of this at this layer. We're just saying, I'm just like, this is just hypothetical here. And I'm saying Morse you actually have a call sign and all that stuff. So Morse, the medium would be UHF or whatever, right? Or some kind of other frequency, right? So hey, thanks for clearing that up for me. Thanks for calling me out. I love it. So let me just say radio frequencies, because some are long haul freaks, and you can send TCP/IP over this too. And actually, what's funny, that's what Wi-Fi is. Wi-Fi is a radio frequency. All right, so gets up to the presentation layer. So basically, I told y'all that. Let's look over here. Where's this DARPA model? DARPA model didn't have session and presentation layer. It was all one thing. So looking at this is actually pretty much all the same stuff. These three layers up top, the higher layers, is gonna understand. Have you ever got a garbled email and like, what the frick is this email, right? And so if you have a browser, somebody talking about encryption, most of the stuff encryption related and stuff is happening up here. You know, if you're sending out encrypted emails, you're doing SSL, TLS, whatever, all that stuff's up here. All the encoding, all that kind of stuff is pretty much happening in the presentation layer. And your browser would be like the application layer with port 80 or port 443. So that's how that works. That's how this all works. And if I do a reply, it goes down the same way. We just send it back the other way. And that's how it all works. But that's how it works. SSL is definitely not. So somebody asked about SSL. So SSL, I say 5 through 7 are really all the same thing. All that stuff's handled in your browser, right? For sure. All right. SSL is definitely, I would say SSL and TLS and all that stuff are, I believe all that stuff is related to the presentation layer and all that stuff. So even if you look in Wireshark, there ain't no session layer. Even when you do it in HTTP, you know in SSL, there's definitely not no, there's no reference to session layer, even in those situations. But I guess what SSL, what does it stand for? Secure socket layer or something like that. I don't know. I think it stands for secure socket layer. But whatever the dang test tell you, that's what you care about. Because we really don't use the OSI model. I'm telling y'all, what y'all really use is the DARPA model. This one, because the internet and all the research was built on this DARPA model. So there's applications, and those applications use the protocols inside of them. That's what I'm saying. So you have your browser is an application, and an application talks on a certain port. Such so and so and so and so. All right. I think this Joker is looking. Is it me or is it not as crispy as it was? I think I might be. I think I might be stress testing this thing because it's not crispy as it was. Whoa, whoa, whoa! All right. It's kind of some lossiness in this. I think I might be taxing this Joker. All right. Yeah, this is definitely not acting right. All right, let's take a break, and I'll be right back. Hopefully I can figure this out. I think I might have messed it up. All right, so what I'm going to do is I'm going to take a 5 minute. I'm going to take a 7 minute break. I'll be back at 10 after the hour. All right. All right. So somebody asked a really good question. They were talking about the different protocols related to like there's different protocols that do email, and I'm just gonna put they're not all necessarily related to Outlook. There are several different ones that are related to email, and it depends on what it depends on. But how it works is some of these communications are between servers, and some of these are between clients, right? And so throughout the internet, what they do is they're going to be relaying traffic the whole way. So using the same kind of stuff. So yes, Marcus was definitely getting some pizza. So somebody said RPC and NetBIOS. I've heard rumors about that before. All right, so I think everybody y'all good on encapsulation, decapsulation. This makes sense. Now the question is this better? I mean, I'm really feeling this dang whiteboard situation here. I can't even lie. I mean, I think the whiteboard is made this whole instruction stuff better. And thanks for bearing with me throughout this whole thing. Yeah. So somebody just asked me a question about. I said some communications are through servers. Yeah, that's true. So let's just take. I drew a server. Let me paste this over here. Let me paste another one over here. So how this all works, I'm gonna draw how this works across the internet, so y'all get a good idea of it. Draw a little network, and I'll zoom in once I get everything in place. I'm just borrowing some of the stuff I got. And so, what I mean is this. A server is just another computer. A server is a computer that typically it is usually designated to do a particular task. If I send an email out through here, I could use different protocols. But the server is going to get that eventually. And I'm going to just pretend. So basically, I'm going to just act like I'm laptop 1.
Motion detected at the backyard.
I'm laptop 1 at acme.com or example.com. So in my configuration, what I'll have, and I think this is taxing. I'm maybe stretching the limits of this application, because it looks kind of weird again to me. It's not crisp like it was, but I think it's gonna work, and I'll work it out. All right, so what I'm gonna do is my mail server is gonna have an IP address. God dang it! It is glitchy. Dang, it's glitching on me again. All right, hold on, people. I'm gonna have to try to get past this So this app is glitching. I don't know if the app, and when I say the app, I mean, oh, hold on a second here. Look at that. Hold on a second. All right, cool. I'm good. I'm good. All right, sweet, 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 sweet. All right, like I said, I'm getting used to the app. I'm getting used to this app. I love this app. So how this all works, and this definitely, everything I'm talking about is evergreen. It's going to matter for networking, and it's going to matter with security. And all the examples that I'm giving you, I'm trying to give you good examples for why this matters to security, and why it matters to internet networking for that matter. So typically, if I'm going to send out an email, there's a couple different options. So say that the protocols we know the SMTP may be used. POP3 is usually used to retrieve emails, if I'm not mistaken, but it could be all different. So I'm communicating with this server here. This server, let's say that this server is mail.example.com. This server is my local email server, so I'm sending and receiving email from this local mail server. This mail server is, of course, going to have an IP address. So this is a two-way situation. When I'm sending email, I'm sending and receiving from here, right? And this is a mail server. So, but how the whole OSI, the encapsulation and decapsulation, 100% works here. It's going to do the same type thing. It's going to look at it. Oh yeah, well this is, but I'm gonna send this to somebody else. So the mail server, it does the same thing to the internet. So this big cloud over here is the internet. It's going to be sending and receiving emails from all over the world for you and your organization. So this is the crazy internet. So your traffic is bouncing all over the internet, and it gets to this other mail server over here. This is the mail server. This mail server is going to be sending and receiving traffic for this company. So everybody's email server. This is going to be. I'm going to say this name of this machine is mail.example.net. Different domain, right? Different domain, and they might have a different setup. They might not be running Outlook. They might be running Gmail. They might be doing whatever. But when it gets to the server, it's going to arrive at that destination. So let me zoom out a little bit here. So what we're saying here is that whole encapsulation, decapsulation process is happening at every step of here. And this is just a small example of this. It's like I'm looking at it, boom, no, it's not for me, pass it on. Looking at it, not for me, pass it on. But when it gets to someplace, mail server, and I have this client over here, and I could be using different protocols as well. I could be using a variety of protocols, but that machine is going to see what kind of traffic it is, and it's going to route it to the proper application. So next time I check my email, I hit refresh on email. This stuff is going on in the background, and I get up my fresh new email. So that's how it works. Big picture. Now, where we get security in play here is I'll show you where we get some security stuff going on. So your mail server typically is going to be not directly connected to the internet. So we're gonna move this over here and say that's the internet. So typically you're gonna have a firewall on your network. Dang, I didn't copy that firewall good, didn't I? Let me just go in here up close. Typically, there's going to be a firewall over here. And I'm gonna do a pull aside here. Let's talk about this. Let's talk about a typical network and how a firewall is done, because this is actually super important. So I'm gonna explain something to y'all real quick. I'm gonna leave this diagram like this. This actually worked pretty well. I'm gonna leave this one here. Leave this drawing here. And what I'm gonna do is I'm gonna create another drawing to talk about firewalls and how firewalls are set up on the network. Very important stuff here. All right, peeps, here we go. So a firewall, a firewall is essentially like it's a router, and every network device essentially has switching capabilities, by the way. Switches just switch the MAC addresses so they can send it to the next hop. Routers make routing decisions based on layer 3, which is the network layer, and I would say that most firewalls are what I would call application aware. Now, with here, of course, traffic goes in and out of a firewall. By default, a firewall is going to allow most traffic out, and it's going to deny by default stuff coming into the network. And why this is this it's called the firewall does what we call stateful packet inspection. I saw people talking about their backgrounds. Some people say they were psychology. Some people said they were this. Whatever your degree is, I think college degrees teach people how to learn, and that's it. So whatever your degree's in, it really doesn't matter. You definitely can have a career doing this stuff. All right. So stateful packet inspection. What does state mean? We said that there was a three-way handshake in TCP/IP. That three-way handshake is a SYN, ACK, and an ACK. So super important. Three-way handshake is super important concept for everybody to know. To you gotta know what that is. So what is a three-way handshake? Hold on a second here. We talked about this a little bit. We talked about Wireshark a lot. So if you missed out on it, I'm going to cover Wireshark again for sure. But basically, by default, what happens is the firewall is going to block anything coming internally unless you tell it not to. People poke holes in a firewall all the time, right? So what the three-way handshake means from a firewall perspective is a firewall, this right here would be external. to the firewall. This is like very guarded. This is external. So when people talk about network security, they say network security is kind of like an egg. It's hard on the outside, but soft and gooey on the middle. This is internal. This is the internal network. Internal network is all trusted, typically. So that means when this internal host by default goes out, it's going to send a what we call a send packet out. Now it goes out, and then the three-way handshake occurs. It's going to automatically allow, most times, it's going to automatically allow this traffic to go out. This is how it goes. That's how a firewall initially blocks bad people from coming into your network. Because it does this stateful packet inspection. Now, so if you were, this is let me save this real quick. Now, this is gonna get real good here. I'm getting excited. Make sure that's good. This laptop is an internal user. So by default, internal users are trusted. Now, if I want to get my email, the mail server would never be on an internal segment. It shouldn't be. Should put it like that. So all this stuff is external. This is internal. So notice the sides. I'm saying this is out to the internet. Now there's this thing that we call, if you want to put untrusted things in your network, there's this thing that people call a DMZ. And I'm gonna do the DMZ. DMZ is not trusted. Let me change this color of this real quick, so we don't get this confused. DMZ. This DMZ is what we call. This actually comes from the Korean the space between Korea and North Korea, South Korea, North Korea. So it stands for demilitarized zone. Dang, I hope I spelled that right. This is what that stands for. Now, this is areas of your network. These are resources that you don't want to necessarily my dog, she's crazy. These are going to be servers and such that you don't want on your network, because they are talking to people. This is definitely going to be talking to stuff that you do not want. It's basically, they're untrusted. They're untrusted entities that you tell, hey, look, if and you can have, people do have rules on these things. It's just not willy nilly. But you would put your mail server in a DMZ, perhaps. So let's say web server. I want to zoom back in a second. Mail server. If you're setting up something like SharePoint that you want access to on the outside. So those are the kind of things that you would put inside of DMZ. Right? So there's nothing special about a DMZ except it does, your firewall typically, it would have these different zones. And that's what we kind of call them, right? Hopefully this is making sense so far. Somebody said FTP. Yeah, whatever. You can put jump hosts here. jump host meaning that you can connect to this machine and then you can connect to so don't let anything come directly into here. And there could be a lot of DMZs, by the way, right? These DMZs are something everybody's using right now. This in a DMZ is probably your VPN, your VPN concentrators is what we call them. So if you're connecting to VPN, right, you're probably connecting to some sort of DMZ, right? So that means at home you can come through internet. So this is an internal user. So this is happening in a lot of companies right now. Let's call this an external user. All right, so this external user can VPN into here, and many times they're going to be able to access their email, their internal web servers, SharePoint, and all that stuff. Now, by default, what's different between a DMZ and this internal network is that people can initiate connections to your DMZ typically. They could be external web services. It could be an external user. So this external user, and actually I think I can do this. Watch this. Click, 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 click. This thing is freaking dope. I wish I knew about this earlier. That guy right there, let me highlight that. An internal, like a home user, can come through here and initiate this connection. Typically, they will have your VPN client, and they may have some kind of policy or something on there, but they can definitely they can get to there, and they can access your internal network in some capacity. Yeah, man, this thing, I like this thing better than a regular whiteboard. I might take my whiteboards now. I'm just whiteboarding this now. So, by default, internal users can get out though, right? Now, this scenario here of connecting to email servers and all that, this is probably all happening in a DMZ. Does that make sense? This is freaking dope. That's how it works. And that's how, when you hear somebody talking about the DMZ and firewalls and all this stuff, that's how it works. Now, let's talk about one more thing here. Let's talk about NAT and how that works. So there's two things. There's a concept called NAT and there's a concept called PAT. And hopefully I can explain both of them for y'all. Man, these drawings are so dope. I think I can put these drawings in a book, man. They freaking dope. All right, next drawing. Next drawing, I'm going to explain to you NAT and PAT. So, the same thing applies. You got an internal user. This internal user's IP address is going to be a private IP address. All right. So, see, that's private. I'm gonna always try to say this is like a trusted user, so it's gonna be green. You know, this person's internal. So internally, I'm gonna be talking about by this address. I'm gonna change this up just for it's gonna be .21. I think the code view is also where's the font at? This is better for an IP addresses. So, what happens here, if I was doing, there's this thing called, whoops. So the term that we're covering right now is network address translation. Now, there's two different things. There's NAT and PAT. All right. So let's go over NAT first. If somebody says NAT, this is what they're talking about. So how this works is when you're doing NAT, you typically have a one-to-one mapping. I'm going out to the internet. This is internal, right? And then when I leave out here, the firewall is going to give me a different address. It has this thing called a pool of addresses. So let's say NAT pool. Now on the outside, say this thing in a pool, what the pool looks like, and this is rarely used. I'm gonna just tell you straight up. This is rarely used. But what that pool looks like is it looks like this. It looks like I'm a class C internal, right? And I'm gonna translate all these different things to an external address. So I'm gonna just pick something out of my head. That probably wouldn't be right. I'm just doing something random. So basically the configuration will look like this, right? And what this does, and it totally depends on how it's set up. It keeps like a database, and I'm gonna draw this like an Excel spreadsheet. And sometimes it's mapped. Sometimes it's going to be mapped like, and let me just type this out real quick. So sometimes it can look like this: 192.168.1.21. Right? I'm gonna make that green because that's our internal address. Anytime I see that, I'm gonna change that to this address. So we said our external pool is this. .21. Now it doesn't have to match this last octet. Sometimes it could match like that, but sometimes it doesn't. But let's just roll with this. Whoops. So basically what can happen here, say this is 45. And I'm going to make this super easy, 45. So now the pool is limited here. There's only possibility of 253 possible hosts here because this is a one-to-one mapping. And this is how NAT works. All right? It's one-on-one mapping. So any traffic coming inbound that's for .21 is going to be mapped. So say if this was coming through, it would go through essentially. But mind you, this still matters though. It's still stateful orientated. But it's going to translate anything destined for 21. It's going to map it to this IP address. That makes sense? 253 because it's a class C and it's -2. So 255 possible numbers -2. That's 253 hosts. Am I crazy? Is it 254? My bad. It's 256. It's 256. It is 254. My bad. So let's say. My bad. So this has a possibility of 254 hosts for Class C. But the problem with this is you can only have 254 machines inside. So for Class C, the first one is 0. So we talked about this last class. I'm just typing this out so it's there. So this Class C address space. Now this actually matters because this is why NAT sucks. So basically, for NAT, you have to buy an external IP address for every one. For every IP address you have internal, you have to buy an IP address. And I think somebody said that it costs thousands of dollars for a Class C address space. Now, what we're going to do here, I'm going to copy this. And I'm going to show you PAT now. This right here, PAT, stands for Port Address Translation. And people say it's a subset of NAT. And I would agree. So what you can do is you can do what we call overloading with this though. You can do overloading. So what it does is it takes incorporation, it expands this and adds something on here. So with PAT, you can use one IP address. So let's pick 23. And over here, you're going to have this table. It doesn't matter how many IP addresses you have, but what does matter is the port that you're going out on. No, everybody, this is what's happening on your home connection right now. You're using NAT PAT. You have one IP address probably. Some of you have maybe more. You know me, I gotta make it look pretty. And what matters here, when I go out to the internet, remember I told y'all before that what happens here is when you go out to the internet, it gives you some kind of random freaking number like this. This is your automatic. What we call it is we call it a high number port. It's going to give you that automatically every time. So, and it's totally random. It's totally random to avoid being hacked too, by the way. It's actually a security feature. Back in the day, you could actually, if you just knew what ports were going to go, you could actually hijack people. And what happens on here, when it goes out to the internet, it also does a random high number port as well. And let's say this is I'm trying to make it look good, and hopefully y'all can understand it. Blow it up a little bit because it's concentrated on this table. Now, here it is. These are also random. Right? So what happens is when it goes out to go to Google, it's keeping a record of that port that it assigned to it. Now when Google responds back to this port, it knows to send it to a particular machine. So it's keeping track of internet connections, right, by the port number you go out. So if you go to Netflix, it's gonna like, all right, boom, I went to Netflix from here. So your machine comes up with this port. You hit right here, and it says, okay, cool. They want to go to Netflix. Here's the IP address to Netflix. I mean, here's the IP address to Netflix is Netflix. But I'm gonna, when Netflix hits me back, this is what your home Wi-Fi does. I know that whatever comes back on this port, they're streaming the movie, and I need to send it back to this port. And when it gets back to your machine, that's where the whole stack works. The encapsulation, decapsulation. So what this does, what PAT does, is it allows you to have one IP address and share this with multiple different things. Right? So now remember, this is your source. This is your source port, right? Now, remember what we said. So let me look up. I mean, I don't know what Netflix's IP address is, but let's just say this. How this looks is like this. When I go outbound, I'm going to get a socket, and that socket is random, and I'm going to say, hey, whatever Netflix is, Netflix.com, and it's going to be 443. So whatever Netflix's IP address is, but when Netflix responds back to me, it's sending it back to this port. So what you have is you have a middleman here. The middleman is your router is going to put this on here. Random port to Netflix. Netflix responds. When Netflix responds to this port, it's going to look up its NAT table, and it's going to say, all right, it's going to that machine, 121. That's 121. It's going to forward it back to this machine. To this exact same port, and there you go. And as they say in the UK, Bob's your uncle. And I don't even know who Bob is, but Bob's your uncle. All right, that's a lot. We have a couple minutes for questions. The table lives in the memory on a router or a firewall. Only thing a firewall is something that blocks incoming connections. Yeah, every time you start a connection, it's a random port. Somebody asks, "Is the random port generated?" It's every time you do a connection. All right. Hopefully y'all enjoyed this. Is there a good place for local dot rules? Uh, Certainly. I would do an exact explicit search on Google for get local rules to set up. There's actually tons of forums, tons of stuff on the internet, and hopefully we'll be able to share some of that stuff. What I want to do here is I want to make sure. Yeah, so the subnetting comes into play a little bit here. So somebody asked, what does subnetting come into play? So remember we talked about IP version 6? The reason why we don't need so much IP version 6 now is because you have private addressing. You have a lot of private addressing, and you have this PAT and NAT now. So the subnetting bit, I mentioned it a little bit here. We're going to beat subnetting into the ground, by the way. So the subnetting here was, this is a Class C address. This is a Class C host right here. And now we'll go over the math and all that stuff, and we're gonna beat that into the ground because you need to know that. But what's important to understand is the number of hosts here. That's where it comes in. So many of the things that we're talking about here is interdisciplinary, is what I would say. It's interdisciplinary in the fact that to be really good at network security, you need to understand subnetting. And when I go through this thing, even from a business perspective, why you need to know that if you try to do NAT, you're going to spend a lot of money unnecessarily, perhaps. Now, there are cases when you need to use it. What I'm trying to do is encourage y'all to understand networking really well. And I want you to understand the security implications of this, because that's what it is. I mean, you look at some of these things we covered, and we covered a lot today. To be able to properly understand and articulate that a mail server operates like this, but at the same time, by the way, you're probably going to put a mail server on a DMZ, and what that DMZ means. This is like, if you build your network right, what I found is that when people don't build the network right, that's when, if you actually built your stuff right, you're going to notice when somebody tries to attack you, it's going to be super hard for an attacker to maintain a foothold in your network if you build it right at the beginning. And I know that for sure. All right. I'm gonna get this video uploaded as well. Hopefully y'all learn something. I'm really feeling this whiteboard. We're gonna go back to we're gonna do hands-on and stuff, but I really want to cover this stuff. And I think what we can do is we can go back and forth between the whiteboard. Now, since I really like this whiteboard, we can go back and forth to stuff, but we want to make sure that you got this theory. This is very important to understand. All right, so there's a lot, like I said, in that dang Discord. I'm super busy at work for sure. So what I'll do is I'm I'm trying to be good about this. Hopefully y'all enjoying it. So, hey, can somebody put the I'll put the export on the. I'll try to put it on there right now. I'm gonna save it. I'm gonna save this current one, and I'm gonna upload it right now. All right. I'll see y'all in the Discord. Y'all take care. Is the DMZ behind the firewall? Yeah, the DMZ is technically behind the firewall, quote unquote. The DMZ is right here. So basically, if you look at the back of your router, all the DMZ is different policies per port, right? The internal network is always going to be the one that it does this send thing where it's letting everything out by default. That's why when you're on the internet, you can go to any website you want to. That's what that internal. But all the rest of them, you pretty much have to have some kind of policy. That's how firewalls work. You have to create. Somebody told me a long time ago. It's translations is what we call it. It's translations. So by default, let everything out. But for anything else, you need to have a policy or translation or rule. We call them access control lists, rules, firewall rules, ACLs is a lot of different vernacular. But typically, this is going to require some kind of translation for this to happen. You're going to allow a port to the web server open. You're going to allow a mail server port. Jump host, whatever protocol it is, the VPN concentrator, whatever protocol it is. That's where the rules, firewall rules come into place to allow a DMZ. And like I said, you're going to have multiple zones, right? All right, cool. All right, I'm going to upload, I'm going to try to upload this in the Discord so y'all can download it. I'll figure out how to do it real quick. And I'm going to upload that last video. Sweet. Today's homework. What's the next section? Tell me right now. What's the next section to do? We always try to do two modules. What's the current one we're on? Tell me. All right. Homework is 2.3 and 2.4. Appreciate y'all. So do those. Like I said, the homework's for you, not for me. I want y'all to know these terms. I'm going to be banging in here because if you learn the terms, you're really going to be able to pick up what I'm talking about better. All right. I appreciate y'all. Do 2.3 and 2.4 terms. I'm going to drop the YouTube link in the Discord. So hop in the Discord and I'm going to be active in there for the next couple of minutes. All right. Put the Discord back on here real quick. Oh, somebody got. Is that the channel? Who is that? Is that me? Hold on a second. Is that my channel? God dang! Somebody already got it. That's it. People are already on there. That channel is live. Awesome. That's dope. I put hashtag quarantine sec on there. So if you search for hashtag quarantine sec on a dang thing on YouTube, it looks like it's popping up. All right, y'all take care. Stay safe out there. And I will talk to y'all next week. See y'all next Tuesday. Not quarantine sex. Quarantine sec.